So what we're going to be doing when we're multiplying two sets of fractions, we're going to multiply them straight across, and then we're going to look to see if there's any common factors within the units, and if there are any common factors, we are going to pull them out. And then once we've pulled them out, we can look at all the individual pieces and see if there's anything that we can factor, or that we can cancel out from the top and the bottom, that we can divide out. So let's get to it. When we're multiplying fractions, you multiply straight across. So let's do that. This turns into a squared plus 3a times 15a cubed. And then that's all over 25 times 9a plus 3a squared. Now from each of these units, if there's something shared between them, we can pull those out. So let's have a look at a squared plus 3a. They both share a factor of a, so let's pull that a out, and this becomes a plus 3. A squared is a times a, and 3a is 3 times a. They both have that multiple of a that we can pull out. Just note that if you were to multiply this a back in, you would use the distributive property. A times a is a squared, and a times 3 is 3a. You're going right back to where you were. And then the 15a cubed, there's nothing we can pull out of that, so we'll just leave it as 15a cubed. And then the bottom 25, nothing you can do with that. Leave that as is. And then we have 9a plus 3a squared. The 9 and the 3 share a factor of 3, so let's pull that out. And then a and a squared also share something. They share an a, so pull that out. If we pull 3 out of 9, this becomes 3. If we pull a out of the a, we're left with 1, so just 3. 9a divided by 3a is 3. Now we're going to pull 3a out of 3a squared. If we pull the 3 out and one of the a's out, all that we're left with is an a. Now we're going to look at each of these individual pieces and see if there's anything that they share that we could potentially reduce. So a plus 3 and 3 plus a, when you're adding, the order doesn't matter. 1 plus 2 and 2 plus 1 give you the same result. So a plus 3 and 3 plus a are the same value. So we can cancel those out. We can reduce those down to 1 over 1. And then 1 times anything is just absorbed. So those cancel out. Now we've got this a times 15a cubed and 25 times 3a. So let's deal with this a. We've got a lone a up here and a lone a down here. We could take this a from the a cubed, but we have a chance to completely eliminate one of our units, so let's do that. Why not? Less work at the end. Now we're left with 25 times 3 and 15a cubed. So if you look at 25 and 15, they both share a factor of 5. So let's divide them both by 5. And we'll be left with 3a cubed in the top and 5 times 3 in the bottom. Now this 3 here and this 3 here, they also share a factor of 3. So let's reduce them by a factor of 3. And they're just gone. What we're left with in the top is an a cubed, and in the bottom is a 5. So a cubed over 5. We don't need to worry about any non-permissible values because there are no variables in the denominator. On to the next one. So when you're dividing, nice little trick. We're not going to go through the proof on how to do it, but a nice little trick on to change dividing fractions into multiplying fractions is just reciprocate that second fraction. So let's reciprocate it and then multiply straight across. So 30x squared plus 15x over x minus 3. And then we're going to change this to multiply, and we're going to put the numerator in the denominator and the denominator in the numerator. As such. Now when you're multiplying straight across, You can combine them together, but you could also just look at all the top values and all the bottom values and see if there's anything shared. Before you get into that, let's factor out the biggest thing that we can from each of these. So 30 and 15 are both multiples of 15, so let's pull a full factor of 15 out of there. X squared and x both share a factor of x. So we'll pull out a 15x from those two terms. If you pull 15 out of 30, divide 30 by 15, you have 2. If you pull x out of x squared, you have x. Now if you're pulling 15x out of 15x, you're just left with 1. In this case, we do want to keep the 1. And then that's all over x minus 3. There's nothing we can do there, so we'll leave that as is. Let's just combine them. I prefer to work like that. So now this x squared minus 3x, the x squared doesn't have a coefficient, or it has a coefficient of 1. So the biggest thing we could pull out is an x, so we'll factor out an x, and we'll be left with, if you pull an x out of x squared, you have x. If you pull x out of 3x, you're left with 3. Now in the bottom, 2x cubed plus x squared. The only thing you can pull out is the shared x's. They both have an x times x that you can pull out. So x squared, and you're left with 2x plus 1. Now we're going to look at all the terms in the top and the bottom and look for anything that's shared between them to do some elimination, to do some reducing. 2x plus 1 and 2x plus 1 are in the top and the bottom. Anything divided by itself is 1, so those two are going to cancel out. X minus 3 and x minus 3 in the top and the bottom. Anything divided by itself is 1, so those are gone too. Now we've got a 15x and another x and then an x squared in the bottom. So we can use one of these x's to reduce this x, and we can use the remaining x to reduce this x, and we're just left with 15. That's all for that question. Again, no non-permissible values needed because there are no x's in the denominator. Moving on to the next one, so another division. So we're going to flip that fraction as well and multiply straight across. So this turns into 6 plus x times 2x minus 2x squared all over x minus 1 times 4x plus 24. Take those values and factor out whatever you can. 6 plus x stays as 6 plus x. From 2x and 2x squared, we can pull out 2x, and we'll be left with 1 minus x all over x minus 1. And then there's nothing shared between those two. Between 4x and 24, they both share a factor of 4. There's no shared x between the two terms, so the most we can pull out is a factor of 4. Pull 4 out of 4x, and you're left with x. Pull 4 out of 24, and you're left with 6. Now this is a fun little question because it demonstrates the difference between reversing the two numbers. 1 plus 2 and 2 plus 1, or 6 plus 1 and 1 plus 6, they both give you the same value. So these two numbers, again, they're the same value, so they're reducible. Now this 1 minus x and x minus 1, they do matter. Doing 2 minus 1 and 1 minus 2 would give you opposite values. So there is something that we can do to make them the same. We can factor out a negative value from either one of these. We can factor out a negative 1. So I'll show you what that looks like. So the 2x, and we're going to factor a negative 1 out of this. And what that serves to do is flip the signs of the two numbers. We're essentially taking a negative out of here. And this becomes negative 1 plus x and then over x minus 1 and times 4. Now these two terms are the same. We have a positive x and a negative 1, positive x, negative 1. Now they're cancelable. Notice what we're left with, though, to make them, to reverse them like that, you do have to pull out this negative value, which merely changes the sign of your final answer. There's one more thing we can do here. We've got a 2 times x times negative 1 and a 4 down here. The 2 and the 4 share a factor of 2, so we'll pull a factor, we'll reduce that by 2. And what we're left with is x times negative 1, which is a negative value, so negative x. And then in the bottom we just have 2, so x over 2. Don't need to worry about non-permissible values. There's no variable in the denominator. So now is a good time to pause and try those two questions, and then carry on. Our next example, a little bit bigger. 4a times a minus 1 times a minus 5 times negative 1 times all over 15a cubed times 5 minus a times 12a squared times a squared minus 1. This one's going to be interesting. If you remember from your polynomials stuff, a squared value minus a perfect square is what we call a difference of squares. So this will take a little bit of recognition too in what that form is in order to be able to pull that apart successfully. So let's put these all together though and factor out whatever we can, and we're going to split that. So what I mean by difference of squares, a squared minus 1, that is the same as doing a plus 1 times a minus 1. So we are going to change that a squared minus 1 into this form, into that difference of squares, and multiply straight across. So we'll have 4a times a minus 1 and a minus 5, and then times negative 1 all over 15a cubed times 5 minus a times 12a squared times a plus 1, a minus 1. So we're lots of different units here. Look for anything in the top and the bottom that you can factor out. I'm going to start with this a minus 1. We've got 1 in the top and the bottom. They reduce to 1. This 5 minus a and the a minus 5, remember we can reverse them, one of them, by factoring out a negative 1. So we'll do that in a second though. Let's factor other things before we worry about that one. So let's factor out from this 4. We can reduce the 4 with the 12 there. 4 and 12 both share a factor of 4. If we divide 12 by 4, we get 3. And then we have this a. We've got 3 a's here and 2 a's here, so we can only factor 1 a out. So let's factor one of them out. Let's do the 2, just for easier writing. So this is now 3a, and this is 15a cubed. So let's factor out that negative 1 from the a minus 5 so that we can make it the same value as the bottom. So that'll become a negative 1 that we're factoring out, and then we have, that'll turn into negative a plus 5, so change the signs of both. We still have this negative 1 up here. And then in the bottom, we'll have our 15a cubed, and then we still have our 5 minus a. That will shortly be gone, and then 3 times a. So a little bit more to do. This 5, positive 5 and negative a, positive 5, negative a, they're the same value now, so we can cancel them. Now in the top, we have negative 1 times negative 1, that is positive 1. In the bottom, we have 15 times 3, that's 45. and a cubed times a is a to the fourth. Now we do need to define a non-permissible value that would make this equal to 0, and we can't divide by 0, we know that's no good. So we want to find out what would make 45a to the fourth equal to 0, because that's the value we can't have in the bottom. So you isolate for a. Divide both sides by 45. If you had 0 divided by 45, if you had 0 of something, you split it amongst 45 people, they're all going to get a whopping 0. So a to the fourth is equal to 0. And then to get rid of the fourth root, an opposite operation for that is to do the fourth root of a to the power of 4. You can do the fourth root of 0, and the fourth root and the power of 4 cancel out, and you're just left with a. A number that multiplies with itself 4 times to get 0 is 0. So in order to get 45a to the fourth to be 0, a has to be 0. So our non-permissible value that would make this whole thing no good is if a were to equal to 0. So we cannot have a equaling 0, or that will make our whole value divided by 0, and that is no good. So try this one, pause it, and come back after you try that one, and we'll do the next example. Oh, that was it. Here's the homework.